Welcome to this video on convolution neural network. Convolution neural network, as the name suggests, is a spatial network having a convolution computation into it. So actually this convolution layer helps to extract the feature out of the object. So when the large data set is to be processed for detection of the different features, the convolution neural network makes it easy in processing. So the convolution neural network consists of 4 layers. One is a layer itself, then activation function ReLU type, then third one is a pooling layer, and at the end of this CNN, one fully connected or dense neural network is applied for detection of the object. This actual application is of classification or regression is implemented in this dense layer. The convolution layer helps to extract the features out of the complicated data. So therefore, it gives a distinguished performance with images, speech, audio signals or video. Let's start with the first layer, that is a convolution layer. So convolution is a process in which you convert one-dimensional input image into the different feature matrix. So majority of computation take place at this layer. Requires input data, a filter or what is called as a kernel, and a feature map will get designed, will get extracted from it. So this is called as a kernel, blue color, which is going to scan this image to get the features, and that is stored into the matrix. So first it will do the see this feature kernel moves across the receptive field to check the feature. Means this is slowly going to take the next position. So this is the first position, this is the second position, which will give you the second feature from this area. So like that it will swap the images and finally it will collect the output array like that. So it is a dot product calculated between the input pixel and the kernel, and the output is a feature map. So different features are collected like height, width, or say height, width, or say line or edges. Everything you can collect through this layer itself. So this convolution layer needs 3 more hyperparameters for this layer. The one is how many filters you implement. If you want to increase the number of features collected, then you have to increase the filter. So increasing the filter will increase the convolution complications and calculations. Therefore, more time you need for training. So this is the filter type. Say here it is a 3x3 which is going to scan this image. So a dot matrix of actual input data and this filter will create the output value. So it is a weighted one, so that this weighted calculation is displayed here. Then what is the stride? So that will also decide the dimension of this output array. So stride is nothing but how you will scan by means of this kernel. So you can go by one column at a time, or you may go for 2 columns at a time. Possible. To match the input array size with the kernel, sometimes you have to add the zero padding. So that may be an extra column at the end of the image, or say extra row, that is also possible. So that will make your output array linear one to match the size of the processing. So sometimes this zero padding is applied. After the convolution is done at the end of the every neuron layer there is one activation function is applied. So activation function is of type of RELU. So negative values are rectified to 0 and the positive values are linearly detected. So this helps in finding the nonlinear relationship between the features and increase the robustness of identifying the different patterns. Therefore, it is used after the convolution layer to detect the features, to modify the features. After that, there is one pooling layer is applied because the convolution layer is a complicated calculations are done, and therefore number of calculation or number of parameters goes on increasing during the training session in every epoch. So therefore the dimensionally reduction is done. So parameters are reduced, randomly they are dropped to get the pooling layers. So pooling operations is just like the convolution one, where it also sweeps the filter or kernel across the feature array to get the one, to get the dimensionality. So, but it is not a dot matrix, dot product. It is just simple calculation based on maximum value out of the array or average value out of the some number of atoms in the output feature matrix. So those to find the final output one. That process of reduction of a dimensionality is called as a pooling. Once the convolution layer get finished, a flattening layer is introduced. So flattening layer actually converts the pooled feature maps into a single input layer, single output layer, or a linear vector. Means, for example, if your feature matrix after uh, pooling is 4 dimensional, then a flattening will convert into a linear array like this, which you can apply to a dense neural network, and output of this is whatever you want, a classification, object detection, face detection, all that is done through your application of DNA. So that is necessary for passing the feature for fully connected layer. The last one is a fully connected layer or dense neural network, which actually does the job of classification or regression depending upon your application based on the feature detected by CNN. It connects every neuron of input layer to every neuron of the next layer. That's why the name has come as fully connected neural network. So this is the architecture of CNN. This is the input image which is applied to convolution layer. Convolution layer output is rectified and then sent to pooling, and then again this training is done for convolution, and then the flattening is done. That is, it is converted into the single layer, single array, and a dense layer will do the job of classification or regression depending upon your application, and this is the output. So this is the one convolution step. Like that is the sequential model. So you can add another CNN if you want to increase the number of features to get one, or you can increase this one into this. Because of the multiple complexity calculations, there are problem of overfitting in CNN. So you can do technique of dropout, where randomly you can drop some of the neurons to reduce the calculations, or you can apply early stopping, means you put the number of epoch you can do. If there are a very less improvement in the error, validation error, then you can early all the training process, or you can add some noise injection in hidden layers so that it will become more robust, or you can apply L1 L2 normalization, which will apply the penalty depending upon the weights. So that also you can apply, or you can do data augmentation. Data augmentation means artificially increasing the data size so that the more training will take place. That is by means of rotation or scaling or flipping or cropping. Those things you can apply to the images available with you, and you can do artificial increase in the data set. So application are, you can do image classification, you can do object detection, or you can do facial recognition. So all the image processing, audio processing are very easy with place of CNN. Though CNN is a very takes lot of time for training, the application development becomes easier and fast. So we'll take one of the application, that is handwritten letter recognition, and that is the MNIST database. From that you can get the letters, handwritten letters. So every image is well size or of same size with a grayscale. So every image is of 28 by 28 pixel of grayscale, and it is well centered and normalized. So data pre-processing is already done, so you can directly apply CNN for this application. Total number of training samples are 60,000, and 10,000 you can do for validation. That is also a good number of large number of data set, so that becomes easier. So we'll go directly to the our application. So we will use GPU model for this for Colab notebook. So it is a TensorFlow GPU that is implemented with this. So these are the standard libraries uh, imported for initial stage. TensorFlow, as you are aware, that is the library for machine learning. And Keras is provides structure for implementation of the neural networks and dense neural network. So we have selected a sequential pattern, then sequential pattern, then we have also taken dense, flatten, and for implementation of different layers. Convolution 2D is used for convolution 2D is used for a convolution layer, and max pooling is done, means the maximum out of the final dimension is taken for as a final results. Then you go for splitting of database as our standard method. So total 60,000 test images of 28 by 28 and 10,000 as test images. One of the images shown here, that is the 106 number in X string. So it is of this type, handwritten image of size 28 by 28. Then additional, it is restructured so that we can add a target answer. So 28 by 28 by 1, that is the reshaping of the training and testing. What is shown here. and this is the Y tray, means the target answers, and these are the answers, that is 5, 0. These are the one array, that is the things. Then model selected is a sequential convolution 2D type with kernel size 3 by 3. Activation is ReLU and input is 28 by 28 by 1. Max pooling is done for a pooling layer, and the last one is again flattened, and the dense layers are added with 64 and 64 neurons, and the last one is output classification is of 10 neurons because we want to detect from 0 to 9. The summary of our model is this: total parameters calculation is 3,47,146 total parameters, those will get calculated. Then again, next step is we will compile the model with cross entropy, and matrix for testing is taken for accuracy, and then it will get fit, and then calculation will go on. Total epoch we have selected are 10, so 10 steps of training will take place, and the accuracy is taken for validation. So if you print the total loss and test accuracy, it comes 0.13 for loss and 97% accuracy. If you plot accuracy versus validation, this is the image. The blue one is a training accuracy, and the red one is a validation accuracy during those 10,000 samples. These samples are there. If you plot loss versus validation, loss of training and validation, again the graph is this, that as training samples are more, the loss get reduced, and the validation loss is of orange type. Then here we have plotted accuracy versus epoch, means 10 epoch we have taken. So how accuracy is changed with every epoch is plotted here. You can store the model by means of so that you can use it afterward with .h file, and afterward if you come back, you can load that model from your Google Drive, and then you can start the calculations. So that is the another one which you can take help, that again and again you don't have to go for training. So we will do the prediction now. We will take one image. Say here we have taken one image of 110 in test. It is of this type, and when we will apply that to the model, prediction is equal to model dot predict input image. A prediction array will get formed. So this is the array. So if you see the probability of from 0 to 9, it is 1.3 minus 12, 2.8 minus 11, 1.15 minus 17. So all probabilities are less except 8. 1, it is the highest probability, and 9 is again minus 11 type. So predicted class we have taken. So max pool means maximum out of this array. So that is 1, which is of on 8 position. So the predicted class class is 8. So this is how we can detect the image. So with this the help, you can understand how CNN helps to develop a model for image processing. Hope you have liked this. Thank you for watching this.